Welcome to today's episode, where we're diving into the fascinating world of database management systems. We'll explore some key concepts that shape how we manage and query large datasets, focusing on the differences between row-oriented and column-oriented databases. We'll also discuss the critical role of indexing and how these ideas can help optimize data retrieval and storage. Whether you're a seasoned database administrator or just someone curious about the topic, there's something here for you. Let's kick things off by looking at the two main types of database management systems, row-oriented and column-oriented. Row-oriented databases are designed to store complete records together, which is particularly handy when you need to access entire user profiles or similar datasets. Imagine you're retrieving information about a customer. With a row-oriented database, you can quickly pull all relevant data in one go. But here's the catch. This design can become less efficient if you're running queries that target specific fields across multiple records. In those cases, the database might have to sift through a lot of unnecessary data, which can slow things down. Now let's switch gears to column-oriented databases. These systems organize data by columns rather than rows, which can significantly boost performance for analytical queries, especially when dealing with aggregates. Since these databases only read the necessary columns, they avoid loading entire rows. This makes them ideal for scenarios where you frequently query specific fields. For example, if you're analyzing sales data and only need the figures for a particular product, a column-oriented database can deliver results much faster than a row-oriented one. When you're deciding between these two types of databases, understanding access patterns becomes crucial. Row-oriented systems shine in environments where most columns are accessed together, like in transactional applications where complete records are often retrieved. On the flip side, column-oriented systems are better suited for analytical workloads, where queries usually target a limited number of columns across many records. This distinction really underscores the importance of aligning your database choice with your specific use case. If your application involves frequent updates and transactions, a row-oriented database might be your best bet. But if your focus is on data analysis and reporting, a column-oriented system could give you the performance edge you're looking for. Now let's talk about the role of indexes in database management. Indexes are like lookup tables that enhance data retrieval efficiency, allowing databases to find and access data quickly. They can significantly reduce the time it takes to execute queries. There are two main types of indexes you should know about: primary and secondary. A primary index is typically built over a primary key, ensuring that each search key corresponds to a unique entry. This structure makes data retrieval efficient and reliable. In contrast, secondary indexes can point directly to data records or reference their primary keys, providing multiple pathways to access the same data. This flexibility can be particularly handy for complex queries that involve different fields. Within the world of indexing, we also encounter clustered and non-clustered indexes. Clustered indexes store data records in the same order as the search keys, meaning the physical arrangement of the data on disk matches the logical order of the index. This organization can significantly speed up data retrieval for queries that align with the index structure. On the other hand, non-clustered indexes don't maintain this order. Instead, they create a separate structure that references the data records. While this can introduce some overhead, non-clustered indexes offer the flexibility of allowing multiple indexes to exist on the same table, each optimized for different types of queries. As we discuss indexing, we can't overlook the importance of primary keys in database systems, whether they're relational or NoSQL. Primary keys serve as unique identifiers for records, ensuring that each entry can be distinctly referenced. This uniqueness is vital for maintaining data integrity and optimizing query performance. In relational databases, primary keys are foundational for establishing relationships between tables. Even in NoSQL databases, while the structure may differ, the concept of a primary key remains essential for efficient data retrieval. There's an ongoing debate in the database community about the best practices for referencing data records and how to optimally use primary keys in various scenarios. As we wrap up this episode, we've explored the key differences between row-oriented and column-oriented databases, highlighting how understanding access patterns can guide your choice of system. We also unpack the role of indexing, discussing the distinctions between primary and secondary indexes, as well as clustered and non-clustered indexes. Grasping these concepts is crucial for anyone looking to effectively manage and query large datasets in today's data-driven landscape. Thank you for joining us today. We hope this discussion has provided you with valuable insights and the knowledge to make informed decisions in your database management endeavors. Stay tuned for our next episode, where we'll dive deeper into advanced database techniques and the trends shaping the future of data management.